All right, hello everybody. My name is Kyle Shorey. This is my first lab report. So I'll start off by introducing it, going through the procedure, the model, the data, and then the errors, and then what if and what it means. So to start off, this lab focuses on two electrically charged pieces of tapes and how they interact when you put them within a close distance of each other. Our job is to compare an observed experimental trial to the predicted computational model. And in this experiment, we're aiming to use the data to explore Coulomb's law as well as point charge interactions through glow scripts. Coulomb's law centers around relating the distance between particles with the force of attraction and repulsion, stating that they are essentially proportional, or it's proportional to the inverse square of the distance between them. And we know that like charges will repel each other and unlike charges will attract each other. Some of the equations that we use from Coulomb's law, the force of gravity and the electrical force here, you can see on the right. Here's the diagram that I made. Basically simulating the situation, you have the electric force going up and the gravitational force going down, trying to balance basically. Here's the procedure. So to start off, you gather the necessary materials, clear tape, ruler, two boxes. You measure out two pieces of tape, set up one piece flat on the table with one edge, and then set up the other piece of tape by folding the end over itself to create a handle, and then you place that piece of tape directly on the other piece. And then repeat these steps for another two pieces of tape, and then you rip both of the handle tapes off, creating two charge tapes. You want to place one of them uh, slightly taut with each end on a box, and then kind of like you see in the picture with the cups here. And then you want to place the other one held in the hand underneath it, and then you're going to see the height increase for the one that's on the box, and you want to measure the distance between the one held in the hand and the one that got raised. Then you create a glow script code, and based on the equations and initial values, you compare the results with the observed experiments. So some of the assumptions we made were that error resistance is negligible. We assumed that each piece of tape had the same electron distribution and that all charges on the tapes could be reduced to point charges. Here are the initial conditions. Obviously, the mass of the tape, the length of the tape, some constants like acceleration due to gravity and Coulomb's constant. And then for the code, separating distance was also a starting requirement. Here are the formulas and how we solved for other equations. So F of G equals mg, electrical force equals Q times electrical field. And so basically setting equal the uh, mg to the equation for electrical force, which you can also see here, where we isolated to get Q, which is the charge, and then once we were able to do that, you can see here the equation for electrical field. You can cancel out the Q's, and you can solve for electrical field as well. Here's a computational model that I use. Basically, you see the constants at the top. We have the two tapes to find next, then gravity and the charge that we solve for, then finding the electric field, and then all of our print statements and solving for the last stuff like the net force, the electric force, and all of that. Here are the results from the simulation, so what it actually looks like. You can see that we have electric charge or electric force going up and the gravitational force going down, somewhat balanced. And then the difference between the experimental versus predicted model. So in the model, I decided that the best way to compare them would be through the net force because we know that it's supposed to be at 0. And so when we do it through the simulation, we see that the net force is at 0.37 newtons, which is pretty close. So I'd say that we got pretty close to the 0 that we were expecting, and overall we were able to pretty successfully simulate the experiment. Some potential errors or improvements. I think next time we could probably use like a more permanently charged item, which would make it easier to it would make it more accurate because we'd have less loss of charge in the environment, and in this one there were likely uneven charges. Hopefully that would make it a little bit easier to get even charges. And then there were small rounding errors potentially that make a big difference considering how small the numbers that we're using are. And then what if the electrons had positive charge and protons had negative charge? So I don't think this would actually change any of the observations that we made because as we discussed earlier, like charges will always repel. So even if we had protons instead of electrons being taken away, well, that wouldn't happen, but it would still repel each other because they're like charges. And then why is it important to handle charge tapes as little as possible? That's because when it comes into contact with other things like your hands or other objects, which are either neutrally charged or negatively charged items, they try to get back the lost electrons and they begin to neutralize. And as a result, it loses charge. But yeah, that was all I had. Thank you for watching.